Yeah, that's working. So we're going over logic gates today because this is one of the things that a lot of people have requested across both groups for me to go over, just to go over some of the conceptions. So what we've got here is the notation. Some of you struggled in the exam with going over the notation. So we've got, if you need to do a not over an A or any letter that they give you, it's just a line. Now, to remember, if you want to note this down on your paper, you can do an arrow with a circle on the end, and that is what a not gate looks like. Because obviously they're going to put different notations in the exam. Sometimes they're just going to use the word not. Sometimes they would put the line above it. All right. Now, if you see a dot, between, that is an and. If you see a dot between it, it is an and gate. Now, the and gate, how do we remember it? What is the best way we can remember what it looks like?
Well, it looks like a D.
It looks like a D, exactly. I always look at the last letter and it helps me remember that a logic gate with a that looks like a letter D, that is an AND gate. Now, we don't tend to see this at GCSE. We don't tend to see the letters side by side. But it also means AND, but that's more moving towards A-level. I've actually nicked this sheet from an A-level revision resource that I use, but it's helpful in helping you understand it, all right? So, again, if you see two letters right next to each other with no symbol, it means AND. So that's what that is there. Now, ironically, you'd think, if you were saying this and this, you would think that would be the symbol to use for a plus, but no. A plus symbol is an OR gate. Now, an OR gate, the best way I remember it is it looks like a moon. Alright? So it looks like a moon, and that's your OR gate. So that is OR, and not. Now there's one symbol we're missing. There's one symbol we're missing. Which one is it?
XOR.
It is XOR. Now an XOR looks like that. That is XOR. If you see the notation. Exclusive OR. Now, in terms of the symbol, in case some of you have forgotten what it looks like, again it is a crescent moon. As I said, but you just have a line through it. That making sense? Now, this is important at the bottom here, because if you are looking at equations you've got, if you can remember, it's kind of like BODMAS in maths. If you can remember that brackets are important first, then the not and or. If you can remember the order of precedence, you're going to do better when you're expanding brackets out and working out what the equation should look like if you have to draw it. So if you remember this order of precedence, this is going to help you when you have to draw logic gates. So that's why I put that on the front page for you. So it's brackets, not, and, or. Now, the next thing we're going to go through, so I'm just going to take this off, and we're going to start going through some questions. Now, the first one I've got here, I'm only going to cherry pick some of the questions that I've given you. Now, it says we've got an automated system. Now, let's just recap quickly what these gates are. What is G? And, good. What is G2? So, yep. G3? And good, right, we've got this. Now this is where what we can do is we can move over to, so I'm going to have this side by side here to hopefully help us understand. Now I know some of us in here will be really strong at logic gates, but it's still useful to see how to break it down, because I might have a quicker way of doing it. Now, first gate I'm going to look at X is T and M. So X is T and M. So x refers to t and m. What I tend to do when I do logic gates is I look at what I'm using and I make a little note of it and I draw arrows to help me sometimes. So I know that x is using t and m and it's an AND gate. The golden rule of AND gates is that we must have two true conditions. So if we go down here, that's not true. 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 But that one and that one is true. Now, if it was an AND gate with 3 inputs, again, you'd need all 3. It's not, the rule isn't 2 inputs, it's all right? So, for an AND gate, we've got these here, true, true, is true. Now, A is quite easy, alright? So I'm going to draw an arrow from A to Y to help me out. It's a NOT gate. The general rule for a NOT gate is it's the inverse, okay? So I'm going to say that 0 becomes a 1, that 1 becomes a 0, that 0 becomes a 1, that 1 becomes a 0, that 0 becomes a 1, that 1 becomes a 0, that 0 becomes a 1, that 1 becomes a 0. We have one more gate left that we have to work out. G3, which is equivalent to P. Alright? What does G3 use? It uses an AND, and it combines X and Y. So I've run out of space, and this is getting a bit messy up here, so what I can do is make a note that I'm using that there. Obviously you don't get marks from this, drawing the arrows from the examiner, but if it stops you making mistakes as much, because I know I'm just using these two. So X and Y, and it's an AND. That's, then there's not 2 on, so it should be not 2 on, 0. Okay? It's just a technique that I use, you don't have to follow it, but generally speaking, if I make notes, I can figure out what conditions go where. Alright? Again, you'll be able to recap and watch this video back to see how I've done that and take it a little bit slower than what I've just done. Alright? So that's that one. Okay. Now I'm not going to go over this question because based on what I've just done, you should be able to answer those now. So I'm going to give you another question. We're going to go to, can we please go to question 6? Alright. Now at the top here, we're going to change this into the notation that AQA use just as good practice. So what I've got here is I've got B and not A, or B and C. So B and C, I'm gonna work on this first. What symbol do we use for AND? So I'm going to go B dot C there. And again, I'm going to open these brackets here. I'm just going to write it exactly as it is. Oh gosh. I'm going to make my brackets bigger just so it... And we got an OR gate here, so that is a plus. That says not A, so A is going to be a line above it. And B and B dot. Now, really, we don't need that bracket there, alright? But I'm just converting it the way it's written so you can visualize it. If you see a few of these, it might be good practice just to write them out in the AQA notation so that you've got a really good idea for it. Now that we know that, let's have a look at this. What was the rule of precedence? What do we start with first? Yes, remember that. We start with brackets first. So let's have a look at this. So we're going to go into our brackets first. But then what was the next most important one? Again, not, all right? So we know, all right, that it's B and not A, or B and C. Right. Which gate should we work on first? I generally start backwards, but let's go for 1. What do we think gate 1 is? Why do we think that? Yeah, because it's B. Yeah, B. And what's that symbol? And yeah, all right. So gate 1 is? Yeah, so you can draw that on there. And we know that it's combined with the dot, which is a AND gate. Good. Gate 3, alright, if we have a look here, B and C. So we know we've got the 2 there. What's connecting them? What gate? Which one? AND. Good. And gate 4 is, yeah, it's this symbol here, because we've got brackets first, and then we've got the OR. So this is our OR gate. Now these questions are pretty much asking that. But again, remember our rule of precedence, and it will help you work out these. If you need to, sometimes they will give you the inputs in the question. You can actually test your outcomes just by drawing like a 1 there and seeing what the output would be. Alright? So there's ways around it. Again, you'll be able to watch this video back, so don't panic. Right. Yes?
How do you know that gate 4 is or not?
Because of this here.
Oh,
Yeah? So this is this gate. Because if you look, it was brackets first. We've worked out our brackets. So they're the brackets. Because that was not A, that was the first bracket, which goes there. Then the second bracket combines the use of that gate, which was that one. That is this gate here. But then we're combining that using this symbol, which is an OR, which is why we know that. Yeah? Okay, we're going to go on to question 9. Now question 9 is a little bit more complicated, and it will require you to use an AND, an OR, and a NOT. But if we look at that, let's have a look at it. We've got the sewing machine running is either on or H is on, but not both can be on at the same time. Now, realistically speaking, what is that? It's XOR. It is. But we're not allowed to draw an XOR for this. Because it says you should only use an AND or NOT. Now, what that means is you've got to combine your outcomes and work out what's going to happen. Your best bet with questions like this, there's one way you can do it. You can actually draw, some people's approach is to draw out F and H and then do mini tables of the gates to see what the outcomes would be. If that helps you visualize things. Some people do an AND, an OR, and a NOT for them. Sorry. Some people do the F and H. Was it FH? Machine is running because the out, yeah. But they draw out what would happen if that was a 1, a 0, 1, 1, 0, 0, 0, 1. And some people, to work these out, do little tables to kind of help them visualize it. Ultimately, what you've got here, I'm just going to draw this out for you, is you're going to have, so, alright, and we're going to use H here, and we're going to use an OR gate first. and we've got that is going to join into an AND. Now I've obviously got this answer quickly because it's one I've done earlier, but when you draw them out, this is where you test your outcomes, alright? So, if, for example, it says, think about it, you've only got 2 possible outcomes you've got to test. But what I generally do is this here, I write next to it to check my ingoing and outgoing. So I'm going to put a 1, 0 there, a 1, 1 there, a 0, 0 there, and a 0, 1. And then I'm going to slowly work my way through it to check it. So if I put a 1 in there, and a 0 there, that's going to be a 1 and 0. 1 or 0, the output is 1. But if I got a 1 and a 0, what's the output? 0. But then that's going to become a 1. That will turn on at the end. So that's my first check. I know that works. 1 and 1. If I put a 1 or a 1 in, I know my output is there. But if I put a 1 and a 1 there, the output is 1. But then what does that do? 0. So I've got a 1 and a 0. Does that work?
No.
Okay, so far so good. If I got a 0 and a 0, 0 or 0 is 0. We already know that that AND gate's going to be a 0, so that's good. Alright, and then we've got a 0 and a 1. So the 0 goes in and the 1 goes in, so that is a 1. This is a 1. And that would be a 0. 1 and 0. That gives us a 0. That turns that to a 1. Therefore, it's a 1. Alright? What I'm saying here is if you can remember this, if this happens to you in any situation, you know what an XOR looks like with multiple gates now, alright? So it'd be worth recapping on how to do that. Yeah.
Is that the only way you can draw it?
There are multiple ways. I will be giving you a mark scheme, alright? That is, honestly, that's the quickest way to do it. Some people tend to do it with 2 NOT gates.
Yeah, that's what I do.
So you can do it with 2 NOT gates. So that I will show you that in the mark scheme, alright? We have one more to go. Alright, that I'm going to go through with you. Now, generally speaking, and I'm going to look at this at the bottom here. Generally speaking, and what I'll do, I'll probably get a scrap piece of paper for drawing this. Let's have a look. Generally speaking, you won't get to have to draw 3. That's not a simple logic gate, really. The expression is, but in terms of drawing it, it's not. But I'm going to show you why. So I've got D. Alright. I've got D, L, and W. Now, I'm going to draw out what the correct answer is to this. Alright, and you'll see why it is. Now it's saying another game circuit, so basically another game circuit will output true if any 2 sensors are activated or if all 3 sensors are activated. This here, alright, is going to combine we're going to have our dot, which is our AND gate. So that is an AND. That is an OR, that is an AND, that is an AND, and that is an AND. So just so you're remembering it here. Now a game uses 3 sensors. We're not going to do this part of the question. The reason why I'm focusing on this one is this says another circuit in the game will output true if any 2 sensors are activated or if all 3 sensors are activated. This has been represented as the current Boolean expression. Now, I want you to bear in mind here, all right, that W and D, they must both be true, and D and L must both be true. Have a think about why that's wrong. So if I show you that this is the right answer, all right, you'll notice it's this and that makes it wrong. It should be or, and I'll show you why. I'm going to draw it out. So I've got W and D. So I'm going to do this up here. We're going for W and D. This is going to look messy, by the way. Now, we've got D and L. W and L. What do the adds mean? So you've not seen a logic gate like this before. There we go. Because I've got D and L, L and W and D. All right. Now it says here in the game that if any two sensors are activated, all three sensors, or if all three sensors are activated. Well, we know if all three, we can use ands. All right. But it's got to be if any two sensors. But an or would do that. So watch here. If D, let's go look at this logically here. D, L, and W. So if D and L are on, so we've got. Have I done that? Have I got L to go with D? Yeah, it's there. If D and L are on, that's a 1. All right. If W and D are on. W and D are on. That is a 1. If L and W are on, that's a 1. Therefore, it says here if any two sensors are activated, because it's 2 at the end of the day. It doesn't say that you can't be activated if it's 3. It just says at least 2. Alright? So I'm going to show you. So that becomes 1 because it's just only one of those needs to be on. Now, think about it logically. Any two sensors, you're going to combine them at one point. A W and a D. Let's try W and L. Imagine that's on, and that's on, but that's off. Because we've used an OR gate at the end of it, that now means that one of these AND gates, only one of the AND gates needs to be true. So by combining it, it will work. Look, W and L. We're going to follow it along. There's the W and L one there. That becomes 1. But even if that's off, the rest are off. But that will still go on as true. If it was D, let's go for D and W. So there's W, there's D. So if that was on, and that was on, and that was off, doesn't matter that this gate's going to be off, or this one. D and L are true, therefore that is true. Now, so obviously you've only got a short amount of time to think in the exam. So what you need to really do is think about what the outcome would be with these. What you can do is just simply do W, D, and work out the outcomes if that is if that is a and that's an and that's an and. Because if something's an or if you used an and, within these and they weren't true, just remember, if you use an and conditions weren't true there, and you have an and there, think about it. It needs to be true across all of them, and it wouldn't work. So it's just more about knowing your and or gates and the outcomes, and you'll get it quicker. I've just drawn it just so you can visualize it. You don't need to draw it in the exam, but I think the more you have a look at how the conditions work, the better that will be for you. So it's just a quick rundown. Hopefully it's helped improve in some way your understanding of logic gates and giving you a different way to look at it. And I'll stop recording there, and then I'll upload it so you can watch it back if you ever need it. All right?